Hello everyone and welcome to another A.I.R tutoring YouTube session. So today I wanted to keep on discussing the idea of slope as we've been seeing for the past two videos. I wanted to go ahead and just do a little bit of a recap of what we've seen, talking about average rate of change, about linear functions and how we identify them, and also about slopes and how we determine their direction. Of course, this is all been based on the idea of rise over run. There are other ways of calculating slope. And if you would like for me to make videos on that, I would really appreciate it if you could comment down below. Maybe you're trying to find slope with 2 points or slope using the formula method, then please go ahead and let me know if you'd like me to make a video on that. But again, this has all just been rise over run. And this has been in the case where you're given a function, okay? So if we do a quick reminder, slope is average rate of change. Of course, change being very important. We always want to be looking for a change in the horizontal and the vertical direction, right? We see here two examples of just some functions where we have y and x representing our coordinate system, our vertical and our horizontal, right? Vertical y, horizontal x. We see m and a in both of these functions that they represent our slope, right? Slope is always going to be that number in front of the x, specifically for linear functions. As we move forward in this Algebra 1 section, you're going to see that there are many different types of graphs, and especially ones that curve and bend and do many movements. So we mainly identify slope as the variable in front of the x when it comes to linear functions. In other words, this format, y equals mx plus b, or any of the other linear formats. And as well over here, we see a is our slope in front of the x, and the two b's are the same in both, which are considered our y-intercepts, okay? If you'd also like me to make a little video explaining these and why we identify them as y-intercepts, feel free to leave me a comment in the comment section. So here we see two examples of m and a being 1 over 5 and negative 1 over 5. These are both the same, roughly the same slope, just that one is negative. And here we see the difference in between them. When they're both positive, we can choose to go one up and one to the right. When they're negative, we need to know which number we're putting our negative sign in. So if we're putting it at the top, then that's going to be 1 down, 5 to the right. If we're putting it at the bottom, then it's going to be 1 up and then 5 to the left. Okay, and we're going to break this down a little bit now that we see the negative side of things and how we graph them. So here we're going to use y equals 1 over 5x. Just a little side note, I did mention about the y-intercept video if you'd like me to make it, but just to clarify why I'm starting at the center or at the origin for each one of these graphs. The reason being because if I were to extend both of these functions out, I could technically say it's plus 0, right? The same thing over here. I can technically say that that's negative 1 over 5x plus 0, right? And if you can see the connection, right, we see that we have the y, the slope, the x, either plus or minus, but in this case plus, and b. And b being our y-intercept, if we look at our y-axis, this number tells us we need to cross it, or we need to have a point at 0, okay? So that's just a little side note, but again, you don't really have to specify that. That's normally a given when it comes to these linear functions. So if you'd ever just have this, if you just have y, slope, and x, it's given that the y-intercept will be 0, okay? So we go into this first problem, y is positive 1 over 5x, right? So this being our slope, we go ahead and choose this point. We've actually already solved it up over here. We know that this slope means that we need to go first. We put our pen on the point, then we go up, then we go 5 to the right. So again, put your pen, your pencil on the point, go up 1 unit and to the 5 units over here, okay? And this is how we went up 1, 5 to the right, okay? Now, that is to get points in the right direction. If maybe I wanted to get points in this direction, which even before we go there, I can already say that this is a line. If I were to go ahead and extend it out that way. Because the main thing that we said, and I mentioned it in the first video, or the first couple of videos, whenever we have 2 points, that is enough to justify a line, okay? You can't have 1 point. You need to always have a minimum of 2 points to have a line. But let's say we're asked to get 3 points. And you know that if you keep on extending, you're gonna get off the graph. Well, what you can do is you flip the sign of both of these, or flip the direction of them, and that'll give you points now in this direction. So in other words, I start from the same point, I choose it, my origin, but now instead of going 1 up, 1 to the right, and let me actually go ahead and write this, right, because this is another or, right? I can say or, I can flip both sides or flip the direction and have 1 down and 5 to the left. And that's even justified mathematically if you have a question about that. Hopefully, if you feel comfortable with your integers, in other words, if you feel comfortable with your positive and negative numbers, we can make a little, just a little recap. Whenever we're multiplying, right? So negative times negative will give you positive. Positive times negative will give you negative. And positive times positive will give you positive, okay? Now this also applies in division, right? If I say negative divided by negative, that will give me positive. Negative divided by positive will give me a negative. And positive divided by positive will give me a positive, okay? So really important here because we see, look, if I put a negative on both sides, I still get positive. So in other words, another way that I can express this positive 1 over 5, I could say it's also this. It's the same thing as saying negative 1 over negative 5, okay? And there we see the justification for this change in direction, right? It's not just that I'm making it up like, oh, just flip the sign on both of them and it'll work. No, there's a mathematical justification for it, which is that we can put negatives on both of them, which as we see over here, negative divided by negative will still be a positive. And that will then change the direction of now instead of the 1 going up, the 1 will go down, and the 5 going to the right, the 5 will go to the left, okay? So again, using that mathematical justification, I can go 1 down, 5 to the left. So starting here at the origin, 1 down and 5 to the left, somewhere over here. And we're going to extend that line out. And there you see the full scope of our line. We have that part and we have this part over here. So again, that's how we can determine it. And if you can notice, positive slope, it's going to be going upwards. Negative slope, if you can already guess, positive is going up, then negative is going to be going down. And our slope is going to justify that. So let me first do the first slope over here, which is 1 down, 5 to the right. That's putting the negative up at the top with the 1. So that's 1 down over here and 5 to the right over here. I land right there. And let me go ahead and apply this one again back at the origin. 1 up and 5 to the right over here. And as you can see, I get my nice straight line right there. And I can extend it out. Little quick note before we finish up. You can apply these slopes on any point of a line. Okay, now of course I define these very clearly by applying the slope and solving for them, but as long as it's a point on the line, I could choose maybe this point right over here. I don't know the coordinates, I don't know the values, I don't know anything. But as long as it's on the line and I apply the slope, I can always find this point and its related points, depending on how the slope changes and things like that. So very important to know that any point on the line, as long as it's on it, will behave according to the slope that it has. Okay, so it'll behave properly with the slope. Aside from that, that's roughly it when it comes to graphing. Again, remember, this has mainly been rise over run slope. There are other ways of calculating slopes. There's actually a couple of other ways. So if you'd like me to make a video on those other ways, I'd be more than happy to. Remember, leave me a comment down below. Like, share, and subscribe. It always helps, and maybe you might be able to help a friend or a colleague of yours that might be struggling in this area of slope. So thank you so much for being a part of today, and have a great day. Bye, everyone.